All right, welcome back. In the previous video, we took a look at how to install an operating system for a Raspberry Pi. We downloaded it onto the card. We put it in the unit, and we booted it up and took a look at a few things. We installed some software on it, just like we would in any Linux operating system. It is a Linux operating system. It's a very nice environment to work in. What we're going to do in this video is build a little electronic circuit and then write some code to make that circuit do a couple of different things. And I have that circuit here in front of me. Actually, while I'm here, I'm going to delete this. We don't need this. I'm going to delete these two wires. Delete wire. There it is. Geez. Delete this one. Delete this one. One at a time. Okay, so there's a switch. So I had put a little debounce capacitor on there, but it really didn't do much. So I developed some debounce code. So this program, by the way, is called KiCad. Let's save that diagram. What I've laid out in here is a 40-pin header, which represents the 40 pins on the Raspberry Pi. And then I've selected the pins we're going to use. This is the ground pin. This is the 3.3 volt power. Ground, we're using GPIO 24 and GPIO 16, just for the heck of it. They were in convenient locations. All this amounts to here is this one is hooked up to an LED, and when you turn this on, it will forward bias this LED. There's a 470 ohm resistor, which is the closest I had to what I really wanted. I wanted 370 ohms, but I didn't have one, so 470 ohm resistor to ground. It'll forward bias this LED and light it up. Not terribly brightly. The current's limited, but that's okay. We'll do something with transistors later on to give us more current for an LED to light up, and perhaps even an external power supply to operate it. As I have a 12 volt power supply that we can also use later on for other stuff. But for now, that'll light up the LED when we fire this GPIO 24. GPIO 16 I've set up as an input, and it's hooked to a switch and a resistor, so it's in pull down mode. When this is open, it's pulled down low by this resistor. When you press this, it turns on 3.3 volts to this input pin, which will activate it, and we'll show how that's done in code as well. There's no debounce on this. There's no need. We'll debounce it in software. So let's shift over to the workbench and build up this electronic circuit, and then we'll write some code for it. Okay, so in this video, what we're going to do, or in this segment of this video, what we're going to do is hook up our little electronics diagram to our Raspberry Pi. And here's the Raspberry Pi. This is the one that I've had for a while. It's in its case. I've taken the upper part of the case off so we can see the pins more easily. I've got it shut off, of course, and powered down. Now, the first thing that we want to do here is hook up the power and ground lines to my project board. So let's make sure this whole project board's inside the camera here. Okay. So what I've got here is a female to male jumper wire, and the power pin that we want, the 3.3 volts, is here on the very upper left corner. That's pin 1, and the ground line is the third one down. It's pin 6. They go across 1, 2, 3, 4, 5, 6. So it's the third one down on that side. So there's our ground, which I'll hook up to the ground side here, and our plus, which I'll hook up to the plus side here. So that's very straightforward and simple. Our LED, the long lead on this one is definitely the anode. I've already checked it on my meter, and we want the anode towards the positive side, so I'm going to put this in my project board with the leads crossing this centerpiece, which is no connection. There's no connection between these and these, but these are connected together in rows, so we can hook wires to jumper that up. Then I have a little jumper wire here I'm going to use. This a little bit of jumper wire, and I'm just going to use it to connect and one of these over here. Come on, get in there. There we go. There it is. And there's our LED hooked up to the power side. Did we want the LED hooked up to the power side? No, we did not. That's not what we want. So we do have power there. That's fine. We'll move the LED over here. We did not want the LED hooked up to power. We'll move the LED over here. What we want the LED hooked up to is our GPIO pin. And I'll use the yellow wire for this. And it's going to be pin, let's take a close look at it here. It's going to be pin 18 is GPIO 24, which is the one we want. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I believe that's that one right there. 18. It would be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yes. Always double check. That's pin 18. And we're going to put this to the anode side of our LED. Make sure I'm on the right row here with it. So we'll stick it right there. Hook to the anode of our LED. Then we need a resistor, and it is the resistor that goes to ground on here. So just hook up to here, any one of these, and to the ground side. Now I'm going to go ahead and hook up the next part of the circuit as well, because we're going to use both in code, and the next part of it is simply a switch and a resistor hooked up to the next pin, which is 16, which is this one here, which is pin 38, I believe, 36, 37, 38, 39, 40, yeah, pin 36. So let's first of all bring pin 36 over, which is the fourth one from this end. 1, 2, 3, 4. Let's bring pin 36 over here to a spot along here, and we'll put in a resistor here. This is a 470 ohm resistor to ground on this. And that's just a pull down resistor and current limiting resistor for when we hook up our switch. Now this switch, the green one, is the center. It's got both a normally open and a normally closed. We'll use the normally closed part of this probably on another one, but what I want to do is hook up this switch so that the green line goes to my resistor and to the pin. No, goes to the power. And then the red line, I guess it wouldn't really matter which one I do. I don't know, my pin got bent there. How that happened. Okay, so then this hooks up right to there. Now we can control these by code. So what we've done is we've hooked up this this little circuit so that we've got an LED that we can turn on and off by toggling this GPIO pin. We've got a switch that will toggle this input pin here, and now we'll go over and write the code and make this do a couple of things. We're going to turn the light on and off, then we're going to detect the switch and also turn the light on and off with the switch. So I will see you back in Linux. All right, so here we are in the Raspberry Pi in Visual Studio Code. And so the first thing we've got to start with is our CMake list.txt. You know that if you watched my other videos, you know that I like to use CMake. So let's begin with that by going right here and creating a file, CMake lists.txt, and I'm just calling this project Blink. So 1 second here. Let me go take a look at my notes. Go to terminal here, get things set up correctly. If we come in here, we go cmake minus version. We'll see that we're on 3.13. That's fine. So what we'll do is we'll go cmake underscore minimum required version 3.13. That'll do. Project is going to be Blink, and it's going to be a C++ project. We're going to add some compiler options, and those options are minus W all. This is all warnings, minus W extra, and minus W no attribute. And now remember, we installed pigpio, pigpio. So we need to do a find, it's find package pigpio. Should be a problem there. And we're going to add an executable called Blink, and it's going to need the library it's going to need blink.cpp, and then we're going to go target link libraries for Blink will be pigpio. And that's it for now. We're going to add another executable to this later. So let's add another file here, and it's going to be blink.cpp, and we'll do a pound include. We need a couple of things. We need IO stream so we can print some things out, and we need pigpio.h, and there it is, part of our system. And then we'll go main, we'll go int main, and we don't need any command line arguments on this one, so we'll just say void, and we'll return 0. Now, pigpio, what do we need to do to use pigpio? Well, there's a little bit of very simple initialization that we have to do. And we'll do that right here in the main. And it is, we're going to say if GPIO initialize is greater than or equal to 0. That means there was no error in initializing our GPIO system. We're going to do something. In this case, we're going to call a function. We're just going to call this one steady blink. So let's create this function, steady blink. Void. What happened? Steady blink. All right, so what do we want to do? Well, first of all, we know that from our diagram we chose GPIO 24 to be our LED. That's what we hooked it up to, was GPIO 24. So let's do here, let's do constant expression, we'll call it LED equals 24. Oh, it's got to be an int, sorry. So that's our LED. We're going to have another one later. In order to turn it on, we need to call a function, GPIO set, is it set? Oh, no, GPIO write. And what does write take? It takes a GPIO pin, so that'll be our LED, and a level. Okay, so we're going to first turn it on by setting it to 1. Now what I want to do is delay a short length of time, so I'm going to go up here and add another include. We'll just add thread for now. And we will go standard, this thread, sleep 4, standard, chrono. And I'll do this in milliseconds. Why not? Standard chrono. Colon. Milliseconds. And we'll make it 1 second. We might shorten that. That's why I did it in milliseconds. So we'll delay a second, and we'll go GPIO write LED 0, and then we'll just copy this. That's the easiest way to do it. Less typing. So that should work. Now what I'm going to do is okay, so got that set up. Just had to set up my camera. Probably cut that part out. All right, so now what we want to do is run this. So we'll make a directory called build. And we'll go cmake ... for the first time. And we'll make. It looks like I did everything right. Now to run this program, so this is accessing the hardware on this machine, we have to type sudo, and then we'll go // blink. And you should see in the corner of the screen, well, we've got maybe one blink out of that. So let's have it run continuously. You probably I'm going to put the screen showing the LED should be somewhere up on this screen, probably over in the lower right hand corner. You should have seen it blink once. Let's go while 1, or let's say while true. And we'll just let this continue to run. Down here, make. And there our LED is blinking. Let's get some of the wires out of the way here a little bit. There we go. There, the LED is blinking on and off, on for a second, off for a second, on for a second, off for a second, because we're controlling that pin with this software. So in the next part here, we already hooked up the button and the switch. In the next part, we're going to show how we subscribe to changes on a pin and get notified when we need something. So let me get set up for that, and I will be back in a flash. All right, so I got everything all set up. Let's open up our cmakelist.txt here. And what we're going to do is add another executable to this that we're going to call button. And it's going to be button.cpp. And we'll have the target link libraries for button also be PIGPIO. Okay, so far so good. We'll create another file called button.cpp. And what are we going to do for button? Well, a little bit different. We're going to do some of the same things we did for blink. So, darn it. First of all, we're going to grab all of this stuff. back over to button. And paste that in. We're going to have another one though. Constant expression. Int button is going to equal 16. Now, I put those delay lines in, but I'm going to make a very simple little function here called delay, just to make it easier for us to call that. And the delay will be in milliseconds. This is just a way of wrapping this. This could be done in a variety of different ways. I kind of like to just create a little delay method, fairly trivial. And then I want another function for setting my LED on and off. And so I'll just paste these in here. These are real simple. So this is just going to write to that LED pin. We called it LED up here. I think I called it pin before in my other work. So we'll call it LED pin, good. And then what we want to do is handle the button. So how are we going to do that? Well, let's go ahead and create our main function and get that set up. So we'll have int main void. We'll do return 0. And then don't think I need that. So we're going to do just like we did before. If GPIO initialize is greater than or equal to 0, then we're going to run this code. And what we're going to do is go GPIO set mode. And set mode sets it either to input mode or output mode. And we're going to use the button. Well, I called it button. I probably should call it button pin like I did before. Let's be explicit. Button pin. And we're going to set it to pi underscore input. This is a define within the library that tells it that it wants to be, we want to be in input mode. So we didn't have to do anything before with this because by default they're set to output. But if we wanted to be kind of thorough about it, we probably should go back to our blink code. And right here before we call steady blink, we should do a set mode on our LED as an output pin, pi output, not out FIFO, output. Just to be thorough and make sure that it is in fact an output pin before we start calling that. But it worked nevertheless, and that's because by default they're output pins. So we set the mode, and now I want to set this. It's not super critical in this mode, but I want to show you. We're going to set pull up down our button pin, and we're going to set it to pi PUD, which means pull up, pull down, down. We're going to set it to pull down, which means internally it's pulled down to ground. And then we're going to go GPIO set alert function. Our button pin again. And a function to call whenever that button pin changes state. And I'm going to call this handle button. Later on, we're going to do some C++ object-oriented magic with this and using the standard libraries to make this a much more versatile thing. And I'll show you how we're going to do that in another video. For now, we're just going to do this. We'll go void handle button. Now this is a callback. The library itself is going to call it. So handle button needs some specific parameters, and what it takes for parameters is first an int called the GPIO, which is the pin that it's responding to. It gets another one that is the reading, and then it gets a uint 32T, that is the number of ticks that have where the tick count currently is. All right, so now we've got our function that will be called whenever that changes. The very last thing I want to do here is just pause the program, and what we'll do is we'll go while true, and because I don't want this to absolutely just run flat out, we're going to call delay 1000. So it'll be sleeping most of the time during that loop. It's just going to loop around, delay 1000, delay 1000, delay 1000. And that's just going to pause the main thread, because this is actually going to be called from another thread that's running inside that's monitoring what's going on. So our main thread just needs to keep from exiting. So what are we going to do here? Well, one of the things we want to do is keep track of the current state of the button. And so I'm just going to create a global here for the moment. We'll do this in an object-oriented fashion later. We'll call it state, and it's low right now. By default, it starts out low. All right. We're going to create inside here a static uint 32T. We're going to call this last tick, and we'll initialize it to 0 at first. Okay, and then we're going to calculate the duration, which is how long it's been since. Now the purpose of what I'm doing here is debounce. As I mentioned earlier in the video, I took out that debounce capacitor. They weren't doing anything. They weren't helping with debounce. Probably got to get a little more sophisticated electronics to do that right. And I didn't feel like sitting and fiddling with that anymore, and I can debounce it in software very easily. So that's what we're going to do here. We're effectively going to do the same thing that a capacitor does, but we're going to do it in code, and we're going to find a way to kind of ignore the rapid bouncing and only pick up the final state that it rests at. So we're going to calculate here a duration, and I want to get this duration in time, in seconds, as a floating point value. So it's going to be tick minus last tick, which is how long it's been since, with the exception of the very first one, which will be off by a lot. And we're going to divide that whole thing by 1 million, because these ticks, because these ticks are in microseconds. And so that will give us the time. Float duration equals, I wondered why that red squiggly was sitting in there. Need to have that. So now we've got the duration. All right, so we're going to do something very, very simple. We're just going to say if that duration is greater than 0.05, we're not going to do anything. We're just going to return from this call. We're not going to change our actual state or change the state of our LED. Otherwise, we're going to call our LED function, and we're going to pass it our reading. Or actually, we could pass it our, we'll pass it our reading. And actually, we don't need state that I created. I actually had edited this code a little bit, so we don't need state. Otherwise, we'll just set the reading. And one of the last things that I want to do here after doing this, though, is go standard cout from duration and the reading. There we go. So we'll see a little printout of it. All right, let's do a make. See if this works. Oh, we got to go to build. We got some warnings, but it looks like we have our button code. So what I'm going to do now is get my camera going over here so that you can see what's happening. Oh, not photo. Video. Okay, the camera's going over there. And now we'll go, remember we got to do sudo because we're accessing low-level hardware, and only root can do that. So here's our button code. It's running. And now if I come over here, and I'll move this out here and press this, we should see the light, and we're not seeing the light come on. I wonder why that is. We're also not seeing any indication here that that was fired. Alert function button, handle button, button pin. I set to 16. Okay, let me double check that I hooked everything up correctly. 16. Oh no, I didn't. I hooked it up to 12. I wanted to be on 16, so I'm just going to move that real quick because now I know what I did. 1, 2, 3. So you can do this, and you want to be careful about doing that. I could have seriously blown something with my Raspberry Pi by doing that. Fortunately, I just hooked it up to another GPIO pin, which shouldn't have done any harm. And there it is. So now, see, I press the button and the light lights, and you can see that it's coming up with the 0 and the 1 and the duration, and it's always more than 50 milliseconds between. If I took that delay out, I'm going to show you real quick what would happen with the bouncing. Let me kill this. If we took this, if we just comment this out, run our button code. Now watch, it'll still light up appropriately, but on occasion we get a whole bunch. That a whole bunch of signals was all the bouncing that button did. And if I kind of push it hesitantly until it's almost closed, there it closed, and release it a little bit, see, I can actually make it do it by just getting it near it. It'll bounce a whole bunch of times. So this simply acts as a debouncer. 50 milliseconds seems to be plenty of time, and it's far faster, far shorter duration than a person would be pushing a button. So that seems to work out really well. And we'll test it one more time with that in it. Oh, now we're getting a bunch of them. Why? What happened? If duration is greater than 0.05, return. Or excuse me, less than, greater than. If duration is less than 0.05, return. Why did I get a bunch of them? Did I not get a proper build? No, I did. I'm still getting some bouncing, so we might have to play with that. Might have to have a longer duration on this. Last tick. Oh, I didn't set last tick. That's why it's not working. So finally, we have to go last underscore tick equals tick. Otherwise, after the first one, it won't get very far. So we're going to make see if it works now. Now we're getting 1 for each press. So I'm pressing it. I'll move over here into the camera. You see I press it, I get 1. I release it, I get 1. I get 0 rather. 1, 0, 1, 0, 1, 0. So that's working, and it's debouncing now. It understands the difference, and I can press it really quick here, and it flashes the LED. So what's happening is I'm pushing the button. The pie's picking up the button press. It's sending a signal out to light up the LED when it's 1, to turn it off when it's 0. And it's happening by way of subscribing to that button on each turn. So I think that's it for this video. Thanks for watching. I hope you liked it. If you liked it, hit that like button. If you really liked it, hit that subscribe button. And I will see you in the next video. Thanks for watching.